Hello everyone, this is Amy. Welcome to my math class. Today we are going to look at some formulas involving perfect squares. Let's get started. This is a common mistake. I'm going to use the geometric representation to explain it. Let's look at this diagram. Here we have a square. The length of the side is a plus b. And the area can be represented by using the expression a plus b all squared. That's one. And now this square has been divided into these four parts. 1, 2, 3, and 4. Then based on diagram, we can see number 1 and number 4, these two parts, they represent different squares. For the first one, the square, the length of the side is a. It means the area of this part is a squared. And then for number 4, for this smaller square, the length of the side is b. It means the area is b squared. Then we can see the left side is not equal to right hand side now, because we still have part 2 and part 3, and then for these two parts, they represent rectangles. They are congruent rectangles, exactly the same. Then what will be the area of these two rectangles? We look at the one of them. So for this one, the length is equal to a, and then the weight is b. Therefore, the area of part 3 will be a times b, and the same for the second part. Therefore, we just double a times b, then we have 2ab. For this formula, the left-hand side, we have the sum of a and b, and then all of it is squared, so it's perfect square of sum. When we expand this one, there are three terms. One, we have a squared, and the other one we have b squared, and then we will have the middle term, which is the twice of the product of a and b. And this formula, we call it perfect square of sum. Now, if we have the difference of a and b, then if we have the square of it, and then how can we get this formula? So in this case, we are going to convert this form to sum. So it can be converted to a plus negative b all squared. And then this b has the same status in the previous formula as b. Then by using the above formula, we will have a squared times twice of the product of these two values, and then plus negative b all squared. And the negative number squared is still positive, therefore this formula can be simplified to a squared minus 2ab plus b squared. So this one is perfect square of difference. That is the difference of perfect squares. Now we have a squared minus b squared. Now how can we factorize this expression? The same, we're going to look at the geometric representation of this formula. So a squared, it represents the area of the square, so the larger square, and take away b squared. So we just cut off a smaller square with the side b, and then we can see a squared minus b squared. It just represents the area of the big square, take away the area of the smaller square. Then it will be equal to these two parts added together. Then we are going to see if we are going to add a line here, and the remaining part has been separated into these two parts. So we have this one here, and we have the second part here. Then we are going to see what will be the length of these sides. So this one should be a minus b. and the same for the middle line. So this side is a minus b as well, and this one is b. Therefore, for this part, it will be converted to the length a minus b. Then how we are going to reorganize this diagram to get the factorized form? Because this side, the bottom side, and this side, they are the same. And then we have already cut off this small square. Then I'm going to relocate this rectangle to the right part, to the right of the remaining area. Then we will obtain this new diagram. Now the new diagram is obtained. Once we have relocated this rectangle to the right, then we have got a larger rectangle. And what will be the area of the new diagram? So the width of the rectangle is a minus b, and what will be the length of it? So here we added this part. It means the length of the rectangle will be a plus b. Therefore, the area can be calculated by multiplying these two terms. It tells us the result of the difference of perfect squares. And normally we can just use dots to call it. It is the third formula involving perfect squares. Now let's conclude. Today we just focused on these formulas and looked at their geometric representation and try to distinguish them by using the areas of the rectangles and squares. Done. That's all for today's lesson. Thank you very much for watching. I will see you next time. Bye.